So for problem set 6, I had number 1, which stated 2 equal parallel chords are drawn 10 inches apart in a circle of radius of 10 inches. Find the area of the part of the circle that lies between the chords. So over here is your drawing, and this green shaded part is what we will be finding the area of. So the first thing I did was I divided this area into a rectangle with 2 sectors. So we can find the area of this rectangle by finding these lengths here, since we know this length is 10, since that's given. And we can do that by using the Pythagorean theorem and dividing this into 2 triangles, since we know that the radius is 10 and therefore the diameter is 20. So we know that the hypotenuse is 20 and that this one leg is 10. So we can do 10 squared plus b squared equals 20 squared. And we get 100 plus b squared equals 400. B squared equals 300. And b equals 10 root 3, because the square root of 300, you can pull out a 100 and the square root of that is 10 and you're left with a 3. So here we have 10 root 3, and we know that the area of a rectangle is just base times height. So we can do the area, I'll use r for rectangle. So the area would be 10 times 10 root 3, which equals 100 root 3. Now, what we have to do is we have to find the area of this sector. So what I did was I pulled out this rectangle and I divided it like this. So we can find this whole sector, because the area, the formula for finding the area of a sector, I'll do this one in blue, is theta over 2 pi times pi r. In order to do this, I divided this into triangles to get this theta, and we know that this degree here is 60 degrees, and we'll see why in a minute. So we know that the theta of 60 degrees in radian form is pi over 3. So you have pi over 3 times 1 over 2 pi. All I did was separate this fraction to make it easier, times pi and our r squared, which is 10. So here your pi's cancel out. So you're left with 100 pi over 6. However, we're not done, because that found the area of this whole entire region here. And we just want the area of this little region here. So in order to do that, we have to subtract the area of this triangle. So redraw this triangle. We can bisect it once again to get 2 right triangles, and just do the Pythagorean theorem again. Because we know that since this bisects this angle up here, it also bisects this area. So we get 5 here and 5 here. And we already know that our radius is 10, and this is the radius. So we know that this up here is 10. So we would do 5 squared plus b squared equals 10 squared. So we get 25 plus b squared equals 100. B squared equals 75. And b equals 5 root 3. Because you can pull out a 25. The square root of 25 is 5, and that leaves you 5 radical 3. Now this Pythagorean theorem shows us how we know that this inner degree is 60, because the rules of a 30, 90, and 60 right triangle states that 60 degrees is always across from your leg that has a radical 3 in it. And that means that this angle up here must be 30. This angle right here is 30. However, we also know that this bisects that angle, and therefore this angle is also 30, and 30 plus 30 degrees equals 60 degrees. So, now that we know this, we can find the area of this triangle. I'll use T for triangle, which is 1/2. So the area of our triangle is 1/2 times 10, which is your base, because we're finding the area of this whole entire triangle, not just one of these right triangles, times 5√3. And you get the area of the triangle equals 50√3 over 2. So therefore, the area of this little portion of the circle over here is going to equal 100 pi over 6 minus 50√3 over 2. However, we have two of these regions if you look over here. So we simply multiply it by 2 and then add the area of the rectangle we found earlier, which was 100√3. And here you can cancel out this 2 and make this a 3 and just get rid of this 2. So you get the area of the shaded region equals 100√3 plus 100 pi over 3 minus 50√3. And that is your answer.